Hey, 8th graders! So we're going to actually start graphing and not just talking about slope. So we're going to start off with what we call proportional relationships, and we're going to use tables to graph at this point. So let's get started. So here's just an example to kind of see the type of relationships we're talking about. We have a video game store that has frequent shopper program, and you earn 4 points for every video game you buy. So right now we're going to draw a graph to model this situation. Things to know is I know that I get 4 points for every game I buy, and then that's what will give me my total points, which I'm calling Y. And so what I'm going to do, we're going to have games at the bottom, games bought technically, and we're going to have total points on the side, and I'm going to count by ones across the bottom, and I'm going to count by fours going up. Oops, and then I put a 5 there. Silly Mrs. Cartwright. So, no, take me back. All right, 4, 8, 16, 20, 24, etc. All right, so I'm going to make a table. I'm going to have games. Oops. Maybe. Games, 2 points. So if I buy 0 games, I earn 0 points. If I buy 1 game, right, I earn 4 points. If I buy 2 games, or I've bought 2 games, then I have earned 8 points. If I have bought 3 games, I've earned 12 points. When I buy 4 games, I have earned 16 points. And the table goes on, but we'll just go with that. So 0, 0, 1, 4, 2, 8, 3, 16, 3, 16. Oh, no one caught that one. Well, you may have, and you're going to call me out on it in class, and that's okay. 8, 12, 16, 20, 24. All right, 4, 16, and then we really could go on if we wanted to. So I have graphed to model the situation. Now, we have been taught in the past that once we've put dot, we draw a line. Now, this is what we would call a discrete graph. Oops, I think that's just TE. Okay. Discrete graphs are when there's no in between. Like, I cannot buy half a game. I can only buy whole number of games. So it doesn't make sense to draw a line because the line means that anything in between would count. So the way I know whether it's discrete versus what we call continuous is, can I do an in-between? So can I do half of something? Does that make sense? Well, in this case, it doesn't. So it's just specific dots. So discrete is when there are only certain situations you can do, right? Whereas continuous is like with time. I could find, maybe I label for the hours, but we could find how much we earned in half an hour or in 10 minutes. So we'll talk more about those as we go. All right, so continuing, noticing that I created more to this graph, but we need 48 points for a free game. So how many video games do you need to buy to have enough points for that free game? So you could say that, you have 48 equals 4G and then solve. That's one way of doing it. But if you have the graph, you can go where you have 48 points and you can come over to the graph, and then I could come down. And so then I need to have bought 12 games. And so that's where we can use the graph to find an answer, or use the graph to fill in a table, right? I know that my Y value is 48 points. I go to the 48, there's my point, and then I follow it down to what its X value is. Easy enough. All right. So what are proportional relationships? Well, there are a few things about proportional relationships. Here are 3 ways we show it, but there are 2 properties of proportional relationships. It always has to start at 0, 0. And the second thing is it has to have a constant of proportionality. Okay, what that is, that's another fancy word for slope, right? Constant rate of change, constant of proportionality, slope. All right, so with our table, right, this one shows 0, 0, so cha-ching. If it didn't, I would just work it backwards and make sure that 0, 0 could be one of them. All right, and then to check constant proportionality, I would do 4 minus 2, which is 2, and 2 minus 1 is 1, so then that's 2 over 1, and then 6 minus 4 is 2, and 3 minus 2 is 1, so then we have 2 over 1, and if I did it up here like I should have done, 2 minus 0 is 2, and 1 minus 0 is 1. So we end up with those constant rate of proportionality. So this is an example of a proportional relationship. Here we ended at, or we're starting at 0, 0, and I go up 2 over 1, right? Or up 2 over 1, up 2 over 1. So it has both things. We start at 0, 0, and we have a slope of up to of 2 over 1, so a slope of 2. And then here, and that's this table is what matches with this graph, which is this equation, right? And we start at 0, 0, and this is our constant of proportionality, so our COP, or in otherwise our slope, right? Constant of proportionality. So that's what a proportional relationship means. In the next video, we're just going to do a whole bunch of graphing proportional relationships so you can see the real world applications. See you there, 8th grade.